Perhaps I'll start with the first question. Thanks again for talks and some insight into the variation that everybody's dealing with looking for this plant. I guess my question is going to be a broad one. I'm looking at a large variability in these plants, the fact that perhaps some things aren't as labeled as they should be, and the need to perhaps organize this in a fashion that it's really useful for consumers, that they know what they're buying, it's truly what they're buying, or further up a step would be using it in a medical situation or for medical purposes. What can genomics do or metabolomics do to try to have some organization around this for the industry, or in terms of solving some of these broader challenges in plant variety?
I'll just briefly give my answer. I don't know if you want more than one, but I think that because there's so many unknowns, because of basically all the flaws that I've pointed out and other people have pointed out with the existing knowledge, we just don't know nearly enough about it, and it's such a complex plant. I would argue that the kind of work that people are talking about, where looking at all of this metabolomics and genomics, is probably the only reasonable way forward, is to somewhat embrace that complexity and leverage these big data approaches to associate any or all of the genetic variation that's out there with specific effects, and then that will let us move forward. Basically, I would argue that Canada is already becoming a world leader, and in place to become the world leader for a lot of this work because of the legal situation and also the related money and scientific expertise, technical expertise that's coming here to do the kinds of things that everyone here is talking about, to really solve some of these key challenges in the plant, but also to understand how our own brains and bodies work and use that to our own benefit.
Hi, so I'd just like to add, I think that genomics is really important for the growers and the producers. That's going to allow them to fingerprint the plant. It's going to allow them to know what plant they're growing. But I think what really is going to matter for the people who presented in the first session, the doctors, is what chemistry is in the plant. And it's a mistake to assume that the genome means the chemistry. Because the chemistry is going to be affected by the growing conditions, it's going to be affected by all kinds of things. And we already know that there are some growers who are applying different sprays to drive the chemistry in certain ways. So if you apply one of the herbicides that inhibits gibberellic acid metabolism, you've now changed the profile. So I think that on the human side, as we talked about this morning, what we really are going to need to have is a full profile and a fingerprint, like they do in Europe for other medicinal plants. So for example, if you're buying St. John's wort in the European pharmacy, it comes with a TLC record of exactly what the chemistry looks like. And they'll often think we're quite crazy for selling it in a health food store. So we really need to start treating cannabis like a natural product and regulating it in the way we regulate natural products, and that requires understanding the chemical complexity in addition to having stable genomics.
So maybe I'll just
one last question.
Yeah. I think there's a fundamental thing that we were kind of talking about. A fundamental question we need to answer as a community about how we want to handle cannabis, and that is, do we want to use an apple or grape model where this specific strain is genetically identical and always the same, we predict things that way, or a model more like hot peppers, where you buy a jalapeno and this is the chemical profile. It's always green, it's always shiny, it's always 3,000 scroll sweetness. That's my preference as a breeder, because you can have a bunch of different jalapeno peppers with all the same chemical makeup that would lend itself to a metabolomic approach, whereas the grape model would lend itself to a sample profiling approach.
thank you so much for this presentation. I was eager to stay so that I could participate and listen to this. And I really appreciate the research of the, I don't know how to pronounce it, the
Metabolite old. It's like a way of making chemistry get money.
Why are you not giving it to me? Please, government, give it to me. And so now that we've gotten to this point, I think the challenge that we actually have right now is that, like you said, we still don't know what we don't know about this plant. And I wanted to pose this question specifically with regard to the sativa and the indica issue, and I'll address this to you. And the problem, Sean, that I have with physician is that I have patients coming in to me specifically saying, I want an indica for night and I want a sativa for day. And having done my research and understanding that by virtue of the fact that the only existence of cannabis we have is because of hybrid ruderalis with indica and sativa for growing conditions in basements, if we really talk about it from a very kind of brown drug prohibition perspective, we don't really know what that is. So how do I educate my patients on the new word of chemovars and cultivars in that context? Because right now, as per the government, they have the words indica and sativa written on here, and I'm inclined to say that patients should be looking at the terpene profile. But then at the same time, I'm concerned maybe I shouldn't be looking at the terpene profile because the chemicals have a bigger place. So how would you advise a physician in this instance to be able to guide patients when they come with very specific requests?
Yeah, so this is a great question. I wouldn't advise a physician. That would be really unwise. But if I were to advise a physician, I think, from the scientist's point of view, all I can do is really speak to the data that we have collected to date, and now you're kind of as up to date as I am. Really, it's an extraordinarily difficult thing to do because this indica-sativa dichotomy is really deeply entrenched in the beliefs of the consumers about what the effects are that these different these different categories of cannabis have on them. And nobody wants to be told that they're full shit, right? So, but the evidence does suggest that they are. So, I'm going to leave it up to the physicians to figure out how to have that conversation with people, but I wish you all the best of luck.
So one small caveat, though, with that is that the existing labeling is actually not done based on the genomics or the actual sort of heritage of a plant, but it's actually done mainly based on subjective effects. So people didn't even pay attention to, even if they knew something about where it came from when they labeled that 100% sativa. It was almost always done because somebody used it and felt like it had a totally sativa effect. And that's basically what that labeling comes from.
Maybe.
Well, I'm not saying that it's rigorous. I mean, it's very subjective. It's very subjective. On the other hand, in some cases that may be broader. They may have some level of broader applicability. In other cases, it doesn't. It just means that basically it doesn't correspond at all to either the genetic lineages or the named subspecies from Linnaeus and Lamarck or whatever. I mean, it's more about what somebody thought would be effect. Right. So that's basically the current labeling.
So the only other thing I can say with this is we do have some additional evidence that there are particular terpenes that are associated with the labeling. But again, the association is significant, but it's not a really great predictor. And so just like the genetics were a predictor of sativa indicative labeling, but not a great predictor. And so it's worthwhile being cautious until we have enough evidence to be able to say, you want to be able to say, what is it you're consuming? What is it? Right? And that's what we're trying to get at here, but it's obviously very complex.
Just one answer, and we'll watch
I just wanted to add one thing. Like, here's an example. Like, if you take OG Kush, so like, okay, OG Kush is like the foundation of West Coast, and if you look at it, it can express limonene. So I showed you those three groups: limonene, which would be considered sativa, because limonene isn't going to make you sleepy and all that. So OG Kush can have depending, same clone, growing in different conditions, will overly express, limonene, and that will be considered a sativa on the shelf. Whereas genetically to us, it's a hybrid. It's a hybrid, it might have some tendencies, but then that exact same clone growing in different conditions will be myrcene dominant and will have the opposite effect. And that's where we're seeing these correlations are popping up in terms of the difference, because essentially these terpene pathways, some people in the room have helped elucidate their pathways, but they have multiple precursors that are the same. So limonene and myrcene, for example, will be depending on the environmental conditions, then you'll get a different expression. So that's where there's a confusion, I think. And again, once people start getting educated and we have, on a large scale of this, massive experiment, people are able to come back and say, oh, look at the terpene profile of this particular genetics, where, there's ongoing efforts, Shoppers Drug Mart, groups like that are trying to characterize the genomic side. And once you have, I think, the chemical profile, we can identify these large groups of, terpenylene, limonene, myrcene, caryophyllene together. I think we'll get a better sense of, maybe a scale in between something that would be considered a daytime or a nighttime. And again, it's going to have to come from both directions. We need to get the input from the patients and also the input from, people are able to grow a particular genovar in a particular condition to have, a stable and consistent product. Thank you.
Question back there?
Yeah, this question is mostly for the first three presenters. Building on terpenes, you all presented on predicting or breeding for terpene chemotype. So are there particular compounds or suites of compounds that you're breeding for or trying to breed out? And are there desirable terpene chemotypes? And if so, what data do you use to make that decision?
Can we use your question to anybody in favor?
The first three presenters.
I'll start. Essentially, this idea of a predictive tool is really in its infancy, and the way that I see it, those categories we show is the broadest level. So if you look at essentially the genetic structure we're seeing, if you look at it on the highest level, there's two groups, hemp and drug type cannabis. When you look at it at a different level now, we're seeing some less granular signal emerge. At this point, I think there's a couple of interesting groups out of the U.S. that are looking at the different pathways and the associations between different terpenes along the pathway, the biosynthesis pathway essentially. So there's associations there, and I think right now it's more about identifying those large terpenes and finding more so the minor terpenes, that those will be the ones of interest. Because we swamped the market with limonene, myrcene, and now terpenylene being different, but there's a lot of other terpenes that are found, and that's the interest in, I think everybody has the same thing. We want to bring in germplasm from other places. We want to have access to the genetic diversity that's shown on that map that really is not present. And the issue with that is those landrace varieties with particular chemical profiles are not suited for the growing environments that we're currently growing. So I think that should be the introgressing minor cannabinoids and terpenes into commercial varieties. I think it's going to be everybody's go-to right off the bat.
Well, I would actually punt to the actual breeder in the room right here.
So I was preparing that to answer the question, but I guess here we go. So from my perspective, our effort it to whatever profile, we're essentially eagerly awaiting somebody to tell us, this is the combination you want, whether it's from the marketing group or the clinical trial group. And we're building a tool set to get there quickly.
Next question.
Can I follow up on that? Excuse me, just, Igor's work on essentially taking an extract from different, very diverse plants, not even knowing their chemical profile, and seeing its effect on a particular target, a cancer cell, I think is the approach that's going to guide us, like you mentioned, Mary. Here's a plant, what is it? Can we discover what the unicorn molecule is inside this particular plant extract or that particular accession that makes it that it has a response for a particular type of cancer? And I think, it's been echoed a couple times around the room, this is personalized genomics essentially. So we have, we'll be able to identify, in a particular model, and then now we're going to have to validate that in the clinic. And again, that's where there's going to be a lot of back and forth between the clinical and the plant science and breeders for targeted preparation.
Sorry, this question is for Susan. Thank you for your talk. I just had more of a technical question, and I don't mean to add to the complexity of the plants, but do you ever see variation in cannabinoid or terpene profile depending on which world bud you actually look at on the plant position?
Oh, absolutely. There's a big difference from top of the plant to bottom of the plant. This is why, for a bunch of the chemocarbs that we looked at, we were very cautious at saying whether these are different. We also looked at two that had different names that were not really significantly different. You could make a case for minor difference, but not significantly different. I'm going to add to that just a little chunk, which is that although we're talking about terpenes and THC and CBD and that class of chemicals, there's a lot else going on there. And so we're really interested in things like the indolamine neurotransmitters, that have serotonin and melatonin, which are targets of many drugs. They have other common drug targets, and so there's a lot more chemistry going on, and we see more in that realm, where that's been outside the breeding program, so that's even a wilder, crazier part of the chemistry, because nobody's selected for it. So the maturity of the bud, what's been sprayed on the bud, how much light the bud had, whether the quality of the light was red light or blue light, whether they stressed the bud in the last 2 weeks before it matured, the height of the leaf on the plant, all of those things give you different chemistry, which is really important for the final product.
We're going to move on to somebody else because we're trying to get as many people as possible.
You can follow that.
You're okay, fine.
I want to thank Susan for making this very important point that we need to look at the genome, but we very importantly need to look at the metabolome, and then extremely importantly, we need to look at the functional space that's right in between. The genome will not tell you what the chemical profile is. The chemical profile gives you a readout, but it's the gene expression, protein expression, and the end of functions that determine the chemical profile. So specifically for terpenes, there is something like 30 or so terpene syntases that have been functionally characterized or that are known in cannabis. Some of them are functionally characterized. And this work can be done now, right? And the good thing in cannabis is we have the research space now to do this type of work. So you can profile every single terpene synthase, and you can characterize which terpene profile is defined by which terpene synthase. How do they play together? So this is no longer like a mystery, but it can be done.
So thank you, York. And York's done a great job of all of that, and that's far outside of my expertise, so I only understand at a very superficial level. But my very superficial understanding is that some of them are promiscuous and can do more than one thing. And so when I tried to understand that, I managed to overwhelm myself with data and give up.
So my question is for Susan and Greg. Both of you spoke about the possibility of identifying Greg, especially your thoughts on the idea of moving towards pure breeding lines rather than clone propagation, and how that same question affects that. Like, what about all the stuff we don't know about yet? I'll go first and then go first. Yeah.
So we had 5 minutes and a very small number of slides, so I didn't really explain. But one of the cool things about different metabolomic approaches now is we can start to deconvolute the data in order to find new ways to discover new molecules. So essentially, through a series of mathematics, you can predict pathways by adding the products of known enzymatic reactions. So if we know what the gene is, we can say, okay, well, you have CBD, and therefore if it glycosylates, you can add on mathematically what that would weigh, and then go look for that. That's an extremely simplified version, but if you want to look at Metaboloanalyst online, it will show you that. So there's some really cool new tools evolving that allow us to find unknowns in new ways. In the past, the only way we had to find unknowns was this thing called bioassay-guided fractionation, which took a really long time. And so, 15 to 20 years to find one molecule, which is why we know so little about what those molecules are. The new tools that are coming, some of the new mass spectrometry, some of the new NMR, is going to allow us to discover new molecules more quickly. So I think we're going to have a ramp up in a technological revolution now. So that to me says we're soon going to have a database of 5,000 things in cannabis, and that'll be easier than for the breeding to develop an optimal fingerprint that you can use and say, you may not know exactly what the structure of some of those things are, but you may know that something with a weight of 1,024 is beneficial for a purpose.
Yeah, sure. So I'll answer the second, or address the second part of the question, which is kind of thinking on it. So I showed you Aurora Sky, which is a million square feet, half a million plants, and it's 4 to 5 cycles there a year. So do the math, that's millions of clones that need to be made, all by hand. It's error prone. There's all sorts of disease issues with mothers. You have to have a huge space to support the mother plant. So it's the clonal propagation is very problematic. And I'm 100% positive it's going to move to a seed-based propagation. The real question is how long is it going to take us to get there? Is that all? Or is there...
I was just wondering, if we're going for pure breeding lines, then there's certain traits we care about breeding true, but there's a lot of traits that we may not know we care about yet. So how do we deal with that?
Yeah, so it's an interesting problem to have as a plant breeder. Unlike a lot of our crops, the genetic diversity is frankly overwhelming in cannabis. It's just essentially unmapped multitudes of genetic variants out there in every imaginable combination of plant architecture. That's everything from branching architecture, leaf shape, how the buds are arranged, density, and then all the chemistry. It's super high dimensional. So really the job of a plant breeder is to select, right, and find what diversity you want to focus on today. It's not going to be lost forever. We can always, it's going to be seeds or tissue culture that we can go back to and reuse. A lot of other crops have had the opposite problem. Like all of North American soybeans are founded on 4 plants, so they have very much the opposite problem. So it's a good problem to have, but yeah, I get where you're coming from. Like, what are we inevitably going to or accidentally going to lose? It's a great question.
We have about 4 minutes, 5 minutes left. Now for maybe 1, maybe 2 questions.
Thank you so much for giving me a second to ask another question. But this question is really regarding kind of a follow-up to this concept about seed propagation and different diversity when it comes to land-race genetics. One of the challenges I have clinically is that my Asian patients do not respond to Caucasian the way Caucasian patients do. Yet the Indian hemp plant, i.e. Indian hemp plant, coming from the subcontinent from Asia, you would presume that the genetics would then therefore affect that particular population the same way, but it learning right now, just from what I heard here, is that the genetics that we have currently in Canada, potentially, or in North America, are Western-based, and therefore are not benefiting this diverse population here in Canada. And I'm not quite sure that's the right way of approaching this, but I face a lot of challenges in my practice when it comes to the fact that my patients say, this doesn't work for me. And I go to another licensed producer, I get another product, and it still doesn't work for me. And then they say, I'm not using this anymore. I want Percocet, I want hydromorphone. And when I have that problem, it becomes very alarming for me, because here I am saying cannabinoid medicine is a great alternative as a pain therapy, but now the cannabinoids themselves are not performing clinically the way I'm expecting based on the genetics that I've seen. So I'm curious how the panel would answer that.
I think that's a great question, and basically all of the complexity that you guys talked about, and then all the complexity we're talking about, they're not even additive, they're multiplicative when they interact with each other, right? So it's a huge combinatorial problem that I'm not sure we'll be able to approach that complexity very quickly to get a clean answer to your kind of question. On the other hand, one model that helps to deal with some of those issues, according to a lot of the doctors I've talked to, is giving the patient a little bit more control over what they're using and how much they're using in order for them to titrate out to the level that works for them. And that actually is a model that in some cases seems to be effective in a way that they wouldn't do with a more dangerous substance. But keeping in mind that there's so much variability among people and how they react to even the same substance or combination of substances. And there's so many variables about what a certain person is actually looking for, and that people have actually found that if a person takes two different concentrations of the same product, for instance, they tend to titrate out to the same actual blood levels sometimes. And so there's actually a lot of self-regulation that happens with cannabis that might not happen with other kinds of drugs. So some doctors approach that by just giving their patients more freedom to try things out.
I think the challenge here is cost. That's actually the biggest issue.
Yep.
People who can't afford the ability to change and titrate up to higher doses, it becomes cost prohibitive, and that's the biggest issue I face as well.
Susan, you want to have one?
Really quick thought. That's true of all plant chemistry. So you have the same issue if you have caffeine. There are great genomic studies, and you mentioned earlier personalized medicine. So ultimately, I think this becomes an interaction between genomes. And so lots more studies needed.
You did one last one.
So just to comment on the pharmacogenomics, and like Susan said, like this is kind of a
general thing. Alcohol dehydrogenase, for example, is the higher frequency of active alleles in the European population or the Asian. But at the same time, all variants exist in all ethnic groups as well. So it's not an ethnic difference, it's more of a personal difference. And if we're able to find these targets, like so CYP2C9 being one of the major drug metabolizing enzymes, if you have both copies of slow metabolizer for that gene, you could be in any of the groups, so that would influence your response, and very often could make you titrate up to a much higher level if you take the higher dose, or if you have both active alleles. You can take 1,000 milligrams, and you're not going to see a huge peak in your especially if you're not taking any other drugs, macro, FAH, CYP2C9, that are metabolizing those drugs and essentially causing some of the other undesired side effects. It could be psychoactivity, it could be anxiety, it could be just a lack of proper any side effects. And again, I think that will emerge once we start understanding a lot of the key markers that we should be looking at. And I think pharmacogenomics is really where it's going to help identify these initial targets and how all physicians have a personal tool that can separate the populations into responders, non-responders, people that require some extra THC, extra active ingredient.
So on that note, I think we're past the 12:15 mark. So I think it was a great session. I think we know that there's a lot of variability on the plant side, a lot of variability on the human side, and also an opportunity to extract that variation somewhere. And we'll be back up on